Welcome to our video on implementing entities and selecting primary keys in database design. In the first step of logical design, entities become tables and attributes become columns. As tables and columns are specified, the crucial step of selecting primary keys occurs. Primary keys are fundamental, and they must satisfy two non-negotiable requirements. First, primary keys must be unique. This means no duplicates are allowed in the primary key column. Second, primary keys must be required. They cannot contain any null or empty values. Beyond the requirements, there are desirable qualities that make a primary key ideal for database efficiency and maintenance. Ideally, primary keys should be stable. This means the key value should not change over time. Primary keys should be simple. Simple keys are easy to type and store, and small values significantly speed up query processing. Finally, primary keys should be meaningless. They should not contain any descriptive information. Let's look closer at why stability is so critical for primary keys. If a primary key changes, all statements using the old value must also change. The new value must cascade to all related foreign keys, leading to performance issues. Now let's elaborate on the simplicity factor in primary key selection. Consider the difference between using a small integer versus a long string as a primary key. Smaller values translate directly to faster query processing and easier data management. The meaningless quality is often overlooked, but vital for long-term database integrity. When a primary key contains descriptive information, that information might change. This forces you to change the primary key, violating the stability rule. While these guidelines are highly recommended, there are occasional exceptions, and specific notation is used in diagrams. The guidelines of stability, simplicity, and meaninglessness are desirable, but sometimes they may be violated for specific design reasons. In standard table diagrams, a clear bullet symbol is used to indicate which column is the primary key. Selecting stable, simple, and meaningless primary keys is the foundation for ensuring consistency, efficiency, and reliability in your database design.
So let's look into this exercise of selecting primary keys, okay? So path name is unique and required, but also complex and meaningful. So path name is not a good primary key. So each path code may come in several sizes. So path code is not individually unique. Path code path size is unique, but not a good primary key because path size is meaningful and may change. Path number is unique, required, stable, simple, and meaningless. So path number is a good primary key. Primary key always require, primary keys are required and unique. So R and U are unnecessary after path number. Okay. So let's get into this exercise so that we check our understanding. A dash attribute becomes a column that is never null. Okay. So let's do this exercise so that we test our understanding. The first part here is a required. Okay. The second part is a single column. Okay, so let's answer part one. A required attribute. Okay. And then let's answer part two. A single column. Then let's answer part 3, which says a surrogate column contains surrogate, okay? Then a surrogate. All right. So we have required, single column, surrogate, and surrogate. Let's check the answers. So here, as you can see, null stands for unknown, or inapplicable. So columns with null values correspond to optional attributes. So columns that are never null correspond to required attributes. Okay, let's check to this. So they say the clue here is it starts with psi. So simple keys such as integers or short alphanumeric codes are usually easy to type, and the process is in a where clause. Let's check this. So the clue here starts with May, and so that is a meaningless. Okay. So a meaningless column contains no additional information for database users and are unlikely to change. So meaningless column make good primary keys. So let's see this. This is stable. The clue here is stable. Is ST. Let's check. Yeah, true. So when primary key values change, they make a scale to foreign key references. So stable primary keys change infrequently or never. The next part is implementing strong